I want to look at Rolle's theorem and the mean value theorem. Rolle's theorem tells us that if f is continuous on a closed interval AB and differentiable in the open interval AB, and if the y values at the two endpoints are the same, then there's at least one c inside the interval AB such that f prime of c equals 0. So here we have a graph that looks like this. Here x has an a value, here's the y value, f of a. X has a b value, the y value is f of b. And notice that if we would connect these two, we have a horizontal line. This tells us that at some point there must be some x value, not necessarily in the middle, x equals c, so that if we take the derivative, find the slope at this point, then the slope of this line equals 1. So there must be some c value between a and b that does this. The mean value extends this by saying if f is continuous on AB and differentiable on AB, then there's at least one d value somewhere in the middle of a and b, such that the derivative there is the same as f of b minus f of a over b minus a. So if we look at the graph up here, here's x is a and here's the y value. X is b, here's the y value. If we connect these two endpoints, then somewhere in the middle, looks to me like about right here, there's a d value, so that if we take this derivative, which gives us the slope of the tangent line, this line is parallel to that line, somewhere in the middle. Let's look at a specific example. Suppose we have f of x equal x cubed plus x minus 4, where x goes from -1 up to 2. Here's a graph of our function. Let's see if we can apply the mean value for this. So if x is -1, we're down here. If x is 2, we're up here. If we connect these two, is there a point somewhere along the curve that has the derivative the same as the slope? So let's see if we can do some calculations. We take the derivative of this, gives us 3x squared plus 1. So if we set this equal to the same as f of b, now in that case f of 2, so if we take 2 cubed plus 2 minus 4, that's 8 plus 2 minus 4, which gives us 10 minus 4. That gives us 6. F of -1, we put -1 in and cube it, minus 1 minus 4, so we have -1 minus 1 minus 4, that's -6. So that means this derivative, 3x squared plus 1, f prime of d, is equal to f of 2, 6 minus -6, all divided by b minus a, or 2 minus -1. So we have 3x squared plus 1, 6 minus -6, so that's 12 over 3 equals 4. So then we have 3x squared minus 1 from each side equals 3. So x equal both plus and minus 1. Now notice, to be in this interval, when we're looking for the value here, it has to be on the interior of the interval, in the open interval. So that means we can't consider -1, so we'll only consider x equal to +1. So d has a value of +1, and at +1, if we take the derivative, we get the value, which simplifies here to 4, which is the same. So here the slope is 4, and the slope from here to here is 4, so in this case our d value is 1.